Howdy. Are you preparing? I am. Some are building EMP proof vehicles. This is also EMP proof because you can row and there's plenty of waterways where you can go. At least here, and probably the possibilities of waterways will just increase in some point. Yeah, that's from yesterday. Just outside of the house. Like, how is it possible that the only spot where you can see anywhere there's a rainbow standing? And it was really intense. You can even see like the purple here. It's really interesting. It doesn't somehow look so intense as it has been here in the picture. Here's the same, a bit increased. And there's also some color visible here. But it got really interesting because I have noticed in some point. No, it's not here visible yet. Also not here. Yeah, here it is visible. There's another one. There is one going there and one somehow to the other direction. They originate somewhat from the same place. I haven't seen anything like that ever. Usually, if you have a double decker rainbow, they have the same arc, they are side by side. They go like that, double decker rainbow, and not like this from the same point, same source, so how to put it. Really funny. And now to some rocks. I've been cleaning these now. I maybe showed some pictures about these already. But check it out. We have craters, bigger ones, and many much smaller ones. And they are perfectly aligned. These are centimeters, not inches. Aligned craters. And here we have different layers of sedimentary deposits, quartz veins. And here you can somehow get the grip about the size probably better because it's on a small scale. But it doesn't affect the interesting or the amount of interest into these formations at all. Maybe we just should somehow saturation, increase the colors because there is color in the rock. It is really, really interesting to watch at these kind of things, especially in your backyard. 5 millimeters wide quartz vein. And then we have these kind of structures here also, which are really interesting because they are elevated and I don't know if anyone has taken out something of these. There might have been once some quartz, but there isn't anymore. And also here we have this kind of really fine structuring here on top of the rock. That's actually not a really sharp picture. But I want to point out how straight those lines are. They are really straight. And they go really transverse to what's like, or against the rock, or how to put it. That's another rock. Similar features. These white lines are elevated. And also here, these are elevated, those brighter spots. And I was thinking about schist and gneiss rocks. And somehow I think that this rock is petrified clay. And this is still just a claim, but I have to make some research as I get time to it. Maybe this should be turned around. Yeah, why not like this? I think they're really interesting, these features here. And since they are so small, but they also appear on planetary bodies on bigger scale. Yeah, that's a cloud, obviously. It looks like a bird. Here are the wings, and that's the eye. Yeah, let's play around. Yeah, a thunderbird. But anyway, about the rocks, still, Andrew Hall was talking about the transversity of quartz veins. And I think that's a really good example here. And there is a better one because this is not really straight. This makes some turns, but I don't have now a better picture of these. But there are some of those quartz veins which are really straight. For example, here on the right, it's a better example. But I wanted to show you still what he has to say about quartz veins because I think it's still interesting, and especially with having this kind of rock in the backyard. Craters, quartz veins, and all this kind of stuff. Really amazing. But let's have a listen to Andrew Hall quickly.
Charge built an electric field across these interfaces in the way a capacitor makes an electric field. Seams became hardened and mineralized, and sometimes evacuated by gases evolved from reactions that channeled caverns as they expanded. The electric field transverse to the seam is why most quartz veins grow transverse across rock seams. They are the electrical expressions left by shock waves and electric fields. The consensus theory of hydrolyzed silica migrating into rock seams by hydrothermal action isn't entirely wrong, but it misses the role of electricity and how it would accelerate the pace of crystal formation. It also misses the role electricity plays in the migration of conductive metals into quartz veins and a number of other things.
Okay. If you watch at this picture, like, it's really hard to imagine that these quartz veins just went there like really slow over millions of years. Doesn't really make sense. I just killed a buck with fire. It was a tick, are parasitic arachnids that are part of the mite superorder parasite forms. Yes, there is one less now because I burned it. There are many, many at the moment here in Finland. It's really annoying. So, I don't like them, but it's a part of nature. Yeah, thanks.